Alright, now I want to take a look at reflecting through axes. So the first one I want to go through is through the y-axis. So I want you to put a point at, let's go -4, 6. So A is at -4, 6. So that's your pre-image. And how many spaces do if I'm going through the y-axis and that's my line of reflection, how many spaces does it take to get from A to the y-axis? All right, so that's a 4. So how many spaces is it going to take me to get from the line of reflection to the new point? 4. 1, 2, 3, 4. So here would be A prime. Now, what are the coordinates for A prime? Did any of the coordinates change?
No. Yeah, from negative to positive.
Yeah, from negative to positive. So I went from -4, 6 to 4, 6. So we kind of write this like this. When we do a transformation, we went from -4, 6, and then we do an arrow to 4, 6. If I go from x, y, which coordinate changed? Did the x one or did the y coordinate change? I went from -4 to 4 with my x. So what happened to the x? It became positive, or even better yet, we could say it became its opposite. So we could say that. So whatever coordinates you start at, if I'm reflecting through the y-axis, which coordinate changes? Not the y, the x. It's one of the weird things in math. It doesn't matter. The thing is, it doesn't matter. If this started off negative, the opposite of a negative is a positive. So it'll just change signs. So we could say if we reflect across the y-axis, the x coordinate becomes its opposite. All right, now we're going to put A prime back onto the second coordinate plane here at 4, 6. So there's 4, 6. And I want to go through the x-axis. So a lot of times I'll do this. I'll actually put a little arrow or something to signify that that's my line of reflection. Just kind of like over here. Just so I know that's what I'm reflecting through. Now, when we reflected through the y-axis, the x-coordinate changed. Which one do you think is going to change now? Yeah, well, let's check. We have to go through this, so there's a total of, that distance is 6, so I have to go 6 here. 1, 2, 3, 4, 5, 6. Exactly, A double prime. It's at 4, negative 6. So as you can see, the two coordinates that changed were my y coordinates. So if I go from xy and I'm going through the x-axis, which one's going to change? The y. Now, another big one is through the line y equals x. And when y equals x, we're going to get the points like 1, 1, 2, 2, 3, 3, 4, 4, like that. And it's going to go diagonally and cut the coordinate plane right in half, like that. Now, I'm going to put a point, totally random. I'll call that point B. And that's at negative 5, 7. Now, you can use your georeflectors to figure out where this is going to go. We'll take that, we'll put the georeflector right on the line. And then you put a point right where you kind of see through it. You're having some issues with those sides, aren't you? Alright, so using the georeflector, I was able to get B prime. So go ahead and find your B prime there. And then figure out the coordinates. What's the x coordinate? 7, negative 5. Now, with 7, negative 5, take a look at the coordinates for B, which are at negative 5, 7, and for B prime, which is at 7, negative 5. How did they change? Yeah, the x and the y, they just switched positions, didn't they? The x became the y and the y became the x. So we can say that if we start at a point xy, we're going to end up at yx. Just like for this one, it was negative 5, 7. It ended up, after reflection, at 7, negative 5. Alright, and to sum it up, if I go through the y-axis, which one's changing, my x or the y? The x. It's always the opposite coordinate of the line you're going through. So this is going to be negative x comma y. If I'm going through the x-axis, which is changing? The y. If I'm going through x equals y, Just switch them. And you can use your georeflectors for that if you want to. All right, does that make sense?